So let us look at the next question. So the question says, the diagram below shows a crate of 50 kilograms. I'm going to draw the diagram for you. So they're giving us a slope, and on the slope we have a 50 kilogram object, and the angle it's making is 30 degrees. They say on the sketch, I see there's an FT acting upwards, and I see that they've given me here a distance, and they've referred to this as delta x. Okay, so the question says, we've got a crate of 50 kilograms sliding down a steep slope. So just be careful. You know, very often when we see this tension, this force of tension on the object, we just automatically assume it's moving up the slope. But this one isn't. They're telling us it's moving down the slope. So indicate it on the diagram, all right? So they're showing me that it's they're telling me it's moving down the slope. The slope makes an angle of 30 degrees with the horizontal. The motion of the crate as it moves down is controlled by a worker using a rope attached to the crate. So this FT here is the force of a worker. All right? But even though the worker is holding it, it's still moving down the slope. All right, so don't be fooled by that, okay? Then it says, okay, the rope is held parallel to the slope. The tension in the rope is 300 newtons. All right, so this force is 300 newtons. And they say there's a constant frictional force of 50 newtons. So now, because this is moving down the slope, in which direction is the force of friction acting? It's acting up the slope. So there's a force of friction, they are telling me, of 50 newtons. All right, acting up the slope. All right. Now, when I look at this question and see that I think this was given to someone as a class test or maybe a revision test. All right, so it's asking for the learner's name and cell phone number and etc. All right, so this question I think was given as a class test. All right, so that is all the information that was given in what we call the stem of the question. So that is what the information was in the stem. There's a force acting up the slope. There's force of friction, but it's moving down the slope. All right, the first part of the question says draw a fully labeled free body diagram. All right, so this was a question 5. So 5.1 says draw a labeled free body diagram. So very commonly asked question, and hopefully you know how to draw these. So remember, we have a big fat dot. I like my students to show the slope and to indicate the angle. You don't have to, but I like just to set it straight. So there's my object on the surface. All right, and now I'm going to show the forces. So what forces do I have? Acting up the slope, I was given that I've got the force of the worker of 300 newtons. They told me that there was friction, so now I know the force of friction is also up the slope because the object is moving down the slope, and friction is always down the slope. Now there's 2 ways of drawing this. When we add force of gravity, the force of gravity acts vertically down, or you can show the component of FG parallel. So either one is fine, but you may not draw FG and FG parallel on the same diagram. If you do, you're going to be penalized. So watch out for that, all right? So I'm going to show you the 2 free body diagrams, and obviously either one is correct, but we never put FG parallel and FG on the same diagram. So you could have either just shown FG acting down. Always remember to show the forces connected to your big fat dot, or you could have drawn it like this. So there's my slope. Draw your nice big fat dot. you would have Ft acting up of 300 newtons. You would have force of friction acting upwards of 50 newtons. And now you would indicate Fg parallel. So either or. And if you're showing Fg parallel, you're not going to show Fg perpendicular. So why not? Because the question says show all the forces acting on the object parallel in the direction of motion. So it's parallel to the plane. So you don't put in the normal force. You don't put in Fg perpendicular. You only stick to the free body diagram and you answer the question. All right, so let me just read the question to you again. So the question says, draw a labeled free body diagram showing all the forces parallel to the slope. All right, so please don't add in extra forces, because if you do, you're going to be penalized. Okay, so it's really an easy question that it's a level 2 question, so you should be able to get your 3 easy marks. Okay, and then also I like you to label things. Okay, so yes, I know it, if you've said Ft equals 300 newtons, that's fine, and Fg, because we all know that's weight. All right, but just make sure you label your diagram nicely. Okay, cool. 5.2, so let's have a look. Let's extend the page a bit. All right, 5.2 says state the work energy theorem in words. All right, now if we go back to our information sheet, if I can just find the correct information sheet, there it is. Remember I said to you we're going to work a lot with W equals F delta X cos theta and W net equal to delta EK. Now this is the work energy theorem. So there it is as an equation. All right, so let's go back. Okay, let's just get back to the page. All right, so the work energy theorem is given by W net equals delta EK. All right, it comes from that equation. So all that it is, it's the work being done by the net force. Now, if you are using this equation and you leave out that word net, unfortunately, you're going to be penalized as well. All right, so it's critical that we use that W net. All right, so it's W net equal to delta EK. So it means it's the work being done by a net force acting on the object, and it's equal to the change in the kinetic energy of that object. All right, so it's quite straightforward, but just remember your terminology, and these definitions you have to learn off by heart. All right, so please, please, please put a lot of effort into it, and you've got lots of time now to get those definitions down to pat, and you learn them off by heart. Okay, so that is 5.2. Question 5.3, they are saying the change in the kinetic energy of the crate. So they're giving me now the change in the kinetic energy, and they're telling me it's equal to 450 joule as it slides from the top to the bottom of the slope. Using the work energy theorem, calculate the length of the slope. So they want us to use W net equal to delta EK to do what? They want us to go and calculate delta X of the slope. All right. So when they're giving it to you like that, please, 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 you have to start with basic principles. Okay, so if you don't use W net equal to delta EK, unfortunately, you're not going to get full marks. And you can't expect full marks when you haven't answered the question. And what I find is sometimes is that we read a question and we don't read to the end of the question, because now we're like preempting and saying, yes, I know this. All right, I've got this. I can do this. But read to the end, because sometimes we miss important pieces of information by not reading the question to the end. All right, so don't just rush through a question. Make sure you understand, make sure you've got all the information to answer. So now we've got to work with W net equal to delta EK. That's our starting point to work out delta X. All right, so let us have a look. So first of all, I can see I've got W net. I can sub in for delta EK, because I was told the change in kinetic energy was equal to 450 joule. So super. So this is where you would be allocated your first mark. Then we can sub in for W net, for delta EK. So delta EK was 450, that was given to us. Now we need to work out delta X, but how? Well, we need to expand. So W net is going to be equal to, we are allowed to expand W net, it's equal to F net, don't forget it's net, times the displacement, times the cos theta, is equal to 450 joule. All right, now we need to try and work out F net. Okay, so going back to our free body diagram. All right, once again, I like you to use grade 11 work. There's a reason why we did it. All right, there's a skill in understanding how do I work out F net. So going all the way back into grade 11 work, how do I work out F net? So we're going to have a look in which direction is this object moving. It's moving down the plane. So now which forces are acting on this object? FG parallel, force of friction, and the tension in the rope. All right, so now we can go work out F net from this information over here. All right, so that is what I want you to do next. So let us use that. So leave the equation and then continue. So we want to work out F net. So F net equals FG parallel minus, why am I saying that? Because this object, they told me it's moving down the slope. All right, they told me that in the stem of the question. So this is FG parallel acting down. So that is why you put it first, because it's acting down the slope and the object is moving down. Acting up the slope was FT, acting up the slope was force of friction. So it's minus FT minus force of friction. Because I'm saying to you, take the direction of motion as being the positive direction, okay? So now we need to go work out FG parallel. So FG parallel is equal to force of gravity multiplied by the sine of theta. Now remember, this comes from grade 11 work. So let us just have a look at our triangle. So if I have force of gravity acting down, we know it's vertically down. This object is moving down the slope. So that's FG parallel. So when I resolve FG into components, all right, so remember, weight on a slope has components. We call it the parallel component of weight, parallel to the surface, or the perpendicular component of weight, perpendicular to the surface. All right, so always make sure you understand the difference between the parallel component of weight and the perpendicular component of weight. All right, so on an inclined plane, and only on an inclined plane, Fg, force of gravity, will be resolved into two components. Okay, so what is making this object move down the slope? It's Fg parallel. It's not Fg, because Fg is acting vertically down. So it's Fg acting down the slope that is making it move down the slope. So that is the force we need to go and calculate. All right, so how do we do that? So these two components are called perpendicular components. Perpendicular means making an angle of 90 degrees. So this angle here will be my angle theta. All right, so to work out Fg parallel, so in this diagram, Fg is equal to m times g. This is always going to be the hypotenuse when you draw it out. So you can't actually go wrong. So you draw Fg acting vertically down. You draw Fg parallel, that component touching your Fg, and then at right angles we draw Fg perpendicular. So now let me just erase this for a bit here. All right, so Fg is always going to be your hypotenuse, and remember your hypotenuse is always opposite the 90-degree angle. All right, so Fg is always opposite the 90-degree angle over here. So let us work out mg. So what was the mass of the object? I think it was 50 kilograms. So it's 50 times 9,8. So let us work that out while we're here. So we've got 50 times 9.8. And that is equal to 490 newtons. All right, so now we've got FG. So we want FG parallel. So now we have a look. Oh, sorry, now I've lost it all together. Sorry about that. Oopsie. Okay. We'll get there. Oh no, it's jumped to the beginning. Okay, there we go. All right, so now I'm wanting FG parallel. All right, so if I have a look, here's my triangle. So if that is sine theta, this side is the opposite, and FG is my hypotenuse. So sine theta, sine of that angle, is opposite over hypotenuse. So therefore the sine, and they gave me that angle, I think it was 30 degrees. So the sine of 30 equals FG parallel over FG. Okay, so let us just have a look to extend the page a bit. All right, oh sorry, I don't know why it's jumping around here. Sorry, that's my mistake. Oh dear. Okay, let me just use the cursor. Sorry, the pen's being a bit otherwise today. There we go. All right, so now sine 30 equals FG parallel over FG, which was 490. So making FG parallel, the subject of the formula is FG sine 30. So that is where I got it from. So you can just learn off by heart FG parallel is going to equal FG times the sine of the angle. All right, so that will be FG parallel. So we go to our famous little calculator. So it's 490 multiplied by the sine of 30 degrees. Oh dear, I put in an extra bracket. So it's 490 multiplied by the sine of 30, and is equal to 245 newtons. Right, okay, so we've got that now. Okay, so if we go back to what we want to calculate, so remember, we are trying to work out F net over here. So F net was equal to FG parallel minus FT minus the force of friction. All right, so let's go. So we've got F net equals FG parallel minus the force of tension minus the force of friction. So this is equal to 245 minus 300 minus, I forgot what the force of friction was. What did they tell us was the force of friction? It was 50 newtons. So they told us force of friction was 50. Okay. So let's just go and substitute in. All right, so now we can calculate. So it's 245 minus 300 minus 50 equals minus 105 joule. All right. Now this question was given in a test. All right, so please don't be put off. Just stick with fundamentals, stick with basics. And when you get an odd question, then you just go with it. All right, so it really doesn't make too much sense. So don't overthink these questions. So often us as teachers, we set questions and we don't always test them, and we're supposed to. You're supposed to do the memo before the time to pick up any issues. Because how is it possible that this object's moving down the slope if then you're obviously going to have an F net which is negative? So it doesn't make sense, but it doesn't matter. It just means that energy was transferred into heat, sound, whatever, because we would have expected a positive answer. But such is life, and we just go with it. All right. Once again, don't overthink. So very often when you guys are struggling with questions, sometimes it's actually the question and it's not you. All right. And this does tend to throw you. So in the exams, just keep going with it, because you will get method marks. All right. So don't try and say, oh gosh, I made a mistake, and go back and waste time. Just go with it. If you've got time at the end, come back and check and just make sure it wasn't you, that you made a silly mistake. All right, so at this point, F net is equal to minus 105 joule. Have we answered the question? So the question said, you calculate the length of the slope. So we're still getting there. So this is a very long question. All right, so we still need the length. So now we're going to go work out that W net, which was equal to F net times delta x times cos theta was equal to, I think it was 145 joule. So now we need to go back again. What was this equal to? Sorry, 450 joules. Okay, so there was a lot of thinking in this question, and this is all equal to 450 joule. So this would be a level 4 question because there's a lot of skills that we are testing to here. All right, so definitely a level 4 question. Did you know about FG parallel? Did you know how to calculate FG parallel? With this, they gave me a tension up the slope. Did you realize they told me it's moving down the slope? Did you identify the direction of motion correctly, etc.? So there's a lot of thinking that's needed here. So there's a lot of analytical, critical thinking. And this is what makes it a level 4 question. All right. So unfortunately, we're not done yet, but we're almost there. So now let us have a look. So W net is equal to F net. So we put in the minus 105, or the 105, sorry, let me just erase that here. So we're going to put in the 105 multiplied by delta x. We don't know what it is, and actually we don't really need this equal sign now. So we could actually just have it like that. So F net times delta x times cos theta is equal to 450. So it's 105 times delta x. Now remember, this F net, all right, is supposed to be acting down the slope, all right? Oh, sorry, and I see here, oh my goodness me. I can see I've been on too much of a holiday, so I just want to erase that. Obviously, what is force measured in? It's newtons. So let us say it's going to be 105 newtons, and it's going to be up the slope. All right, so once again, I didn't give myself enough space. All right, so it's 105 newtons up the slope. So subbing in is 105 delta x. So now, if this object is moving down the slope, in which direction is F net going to be acting? So from that, it is measuring, or it is acting up the slope. So what is the angle? 180 degrees. All right, so it's cos of 180 is equal to 450 joule. And now we can solve for delta x. So we are going to have delta x multiplied by minus 105 equals 450. All right, so let us just go. Delta x is equal to 450. But we want to know the distance. I'm going to drop the negative, divided by 105. And so now we're going to have 450 divided by 105 is equal to 4,29. So the distance is 4,29 meters. And there we go. All right. So quite a difficult question. And obviously, having gotten a negative for F net, it could have thrown you off the course. But you just carry on with the question. And later, if you've got time, you come back and just check that you've done everything correctly. Then just realize it was the question. All right. And hopefully that would help you with that one. All right. So let's look at the next question. It says, calculate the coefficient of kinetic friction on the crate as it moves down the slope. Okay. So now they want us to calculate the kinetic friction coefficient. All right, so this was the question 5.4. So the kinetic friction, or kinetic friction, is given as the coefficient of friction, kinetic friction, multiplied by the normal force. All right, now in order to work out the coefficient, we make it the subject of the formula. We need to know the kinetic friction, they gave it to us, divided by the normal force. So now the normal force, so looking at my triangle, that's FG. This is FG parallel, and there is FG perpendicular. Now from this diagram, so if I'm looking at my slope, so this is the object, all right? So FG perpendicular is acting into the slope. Acting out of the slope, per definition, is my normal force. These two forces are going to be equal in magnitude, all right? So as the force perpendicular is acting into the slope, the normal force is acting perpendicular out of the surface, all right? So if I can get FG perpendicular, I've got the magnitude of the normal force. They're just acting in opposite directions. So that's what you're going to do. So looking at the triangle, we're going to use that sine theta, we're going to use theta, and to get FG perpendicular, we're going to use the cos of that angle. All right, so let's have a look. So here's theta here. So now we're looking at the adjacent side. So because we're looking at the adjacent side, we're going to say cos theta equals FG perpendicular over FG. So FG perpendicular, you can just learn off by heart, is equal to FG cos theta. Now just remember, FG is m times g. So often I find students forget to multiply the mass by gravity. So remember, the object had a mass of 50 times 9,8 multiplied by the cos of 30 degrees. And that will give me the perpendicular force, which is going to be the normal force. All right. So we are going to work it out. So it's going to be 50 multiplied by 9.8 multiplied with the cos of 30, and that is equal to 424,35. 424,35 newtons. All right, so that we can put in here now. The force of friction, what did they tell us was the force of friction again? So if we go back to our diagram, they gave us that the force of friction over here was 50 newtons. So we've got that. All right, so now it's just a matter of subbing in. So this is equal to 50. And the normal force that we've calculated, so remember the normal force is equal to FG perpendicular is divided by 424,35 newtons, and now we just plug it into our calculator. All right, so it's going to be 50 divided by 424.35. All right, and that is going to equal 0.12. So it's equal to 0.12. Now remember, this coefficient has no units. All right, so it's a coefficient, it's a constant, and it depends on the type of surface that you are using and obviously the material of the box. So it will be a constant, and it has no units because we're taking the force of friction, which is in newtons, and we're dividing it by the normal force, which is also in newtons. So the newtons cancel out, and we're just left with the coefficient.